Hello, my name is Faith, and today I will be talking about the American crow and its foraging behavior. Crows have a very diverse diet, and their strong beaks allow them to be able to eat almost anything, ranging from insects, berries, and seeds to reptiles and even eggs of other animals. Because of this, foraging, or searching for food and finding resources, is not difficult, especially in areas with human disturbance like parks. Most of the time, these crows forage and feed on the ground, as shown in this clip. Here we see that this individual forages for some time, wandering and looking around in several directions for resources before it begins to run as it spots its prey and attempts to catch it in its mouth. Unfortunately, it does not look like its prey is caught, and the crow continues to forage. The first level of analysis is causation. Crows forage when hungry, and increasing levels of ghrelin is what stimulates hunger. As a result, crows will use visual and auditory sensors to search for food while also scanning its environment for threats. They make decisions about when to scan its environment, when to look for food, and what food to eat with the aim of minimizing costs and maximizing fitness benefits. As stated by Druckamer and Gilly, choices made by animals in foraging depend on the assessments of time or energy. The second level of analysis is development. Young crows learn the outcomes of certain foraging strategies through experiences such as determining if the quality of the food is worth their time and energy. Acquiring efficient foraging strategies is something that comes later on when inexperienced crows learn what benefits them effectively. Brinton and Curran give an example of this in their article as they state that an inexperienced bird might eat an entire rice cake because it seems to be a lot of food, but those 35 calories might not be worth the effort. The third level of analysis is evolution. Natural selection has favored the foraging strategy that provides the greatest net fitness benefits such as reproductive success or survival. The environment has a strong effect on this as well. Typically, in areas with higher human disturbance, vigilance is decreased, and it would not be necessary to spend time worrying about predators. This was shown in a study by Ward and Lowe, in which they researched the relationship between foraging and avoiding predators. According to them, an individual cannot simultaneously scan its surroundings for predators while feeding, and those that are able to balance the trade offs among costly but beneficial behaviors will yield the greatest net benefits in terms of enhanced survivorship, reproduction, and increased levels of fitness. The final level of analysis is function. Crows forage in order to find food and ultimately survive so that they do not starve. However, while searching for resources, as said before, they cannot effectively scan its environment for threats at the same time. This must be done by balancing the costs and benefits in order to efficiently find food while avoiding these predation risks. For example, an individual must balance out their energy gained and their energy lost to ultimately create a net benefit to successfully forage. Bonter and Sedgwick studied the daily patterns in foraging in free-living birds, finding that foraging often ended before sunset, which suggested that their required level of energy reserves was being reached before the end of the day. This supports the theory predicting bimodality in foraging behavior driven by a trade-off between the risks of starvation and predation. This behavior of foraging relates to the optimal foraging theory, which was discussed in Module 10 of Cogbooks. This theory predicts how animals maximize fitness while foraging, whether this involves the food itself, patch choice, time, or patterns and speed of movement.